Now we are discussing voltage control of inverter by using pulse width modulation. Generally, whenever we operate the AC loads, they require constant supply. That does not mean they require DC supply. Definitely we are operating the AC loads. They require a constant AC RMS, example 230 volts RMS supply. If the supply is low or supply is high, the load might not operate properly. Sir, can you give me one example? Yes, definitely. We will take the single phase induction motor. Its voltage should be incremented in accordance with the frequency. If we are increasing the voltage, the frequency accordingly should increase. But without increasing the frequency of the signal, if we are increasing the voltage, what happens? Then obviously, the magnetic parts of the motor, they will get saturated. Means they don't have the ability to store more magnetic field. That remaining magnetic field forms the heat, because energy is neither created nor it is destroyed. This heat will damage the motor. Because the voltage is increased drastically, magnetic parts are in saturation mode. That caused heat there, in turn it damaged the motor. If we maintain a proper voltage, then the motor runs very smoothly. That will give very high efficiency of the motor, and that will increase the lifetime of the motor. So the summary of this example is, whatever the load we operate, if we give a very suitable required voltage to it, lifetime of that load will increase. Its performance will increase. Its efficiency will increase. Sir, that is fine. But how to give this constant voltage? We are taking the inverter. Sir, inverter supply fluctuations are there. So if the supply is input DC is varying, output obviously it will vary. Absolutely. That's why we are using three methods. First method is controlling of the output AC voltage. Input DC fluctuations might be there. We are concentrating at the output voltage. If the output is higher than 230 volts RMS, we are bringing it to 230. If the output is lower than 230 volts RMS, we are bringing it to 230. We are controlling the output AC, external circuit we are using. Second one is, we are controlling the DC input itself. DC is trying to increase, we are bringing down. DC is trying to decrease, we are bringing up. External circuit we are using. In both these cases, we require external circuit. That is the costliest process. There is no doubt with these two methods we can perform the voltage control, but external circuit means it is a costliest one. So we are not going with them. Now we are going with the internal control. No need to concentrate on output AC. No need to concentrate on input DC. You concentrate on your pulse width modulated signal. So the title heading is, we are controlling the output voltage by using the pulse width modulation. So output voltage from the inverter, we are controlling it by using the pulse width modulation. How we are doing it? Now we are trying to discuss about that. This is the working of PWM inverter. Why we are calling as a PWM inverter? We are controlling the output voltage of the inverter by using the internal method. But for that internal method, we are particularly using the PWM signal. That's why it is a PWM inverter. We are giving two signals. One is carrier wave, high frequency carrier wave. Second one is reference sinusoidal wave. A reference, whenever we get some low marks, teachers will tell, see him and learn. We will take some reference. Whenever we are learning our habits, we take very great persons like Abdul Kalam life story we read, and then we take some reference. How in this situation Abdul Kalam behaved? Why can't I behave in this way? So reference, we are setting a reference. Usain Bolt setting a reference for the Olympic runners. In cricket, a great cricketer is setting a reference how a cricketer should be. Like that, in each standard, in each field, one great person will set a reference. Similarly, here our reference is sine wave. Based on this reference signal, our output signal will vary. Inverter output signal. If we change the amplitude of the sinusoidal signal, output of the inverter will vary. If we change the frequency of this reference wave, output frequency will vary. That's why we are calling it as a reference. There are two signals, one is the reference and the second one is carrier. The carrier we are taking is triangular and the reference we are taking is sinusoidal. We expect our reference signal should decide. That's why whenever the reference signal is dominating the carrier, then the comparator becomes high. Whenever the reference signal is lesser than the carrier, then comparator goes to low. Here we will show in the diagram. There is no need to confuse. Sir, why you are drawing these many triangular waves? Because it is a high frequency signal. More triangular waves are there. Sir, why you have drawn only one sinusoidal signal, one waveform, single waveform? Because this is a very low frequency signal. Generally, message signal is a very low frequency signal, carrier is very high frequency signal. That's why for one waveform of sinusoidal signal, we have drawn many triangular waves. Okay, that's fine. Now we are going with, see here, in this point, at this intersection point, until this point, triangular wave amplitude is higher than the sinusoidal amplitude. That's why output is 0. After this point, sinusoidal signal amplitude is higher than the triangular signal amplitude. That's why we observe a high in the pulse. Whenever the triangular signal amplitude is higher than the triangular wave, then the output pulse is higher. That's what we discussed in this diagram. Now, by using that, we are generating some trigger pulses. So now, number of trigger pulses we are giving. These number of trigger pulses per half cycle, they depend upon the half length cycle of the reference wave, which is nothing but our sinusoidal signal, half time period. Time period is 1 by f, half time period means 1 by 2f. And width of the one cycle of the triangular wave, means time period of the triangular wave, that is 1 by fc. So finally it is fc by 2f. Fc is the carrier signal frequency, f is the reference signal frequency. Reference signal is sinusoidal, carrier signal is triangular. Now with this we will get how many trigger pulses per half cycle we are getting. That information can be known to us. Modulation index is nothing but VR by VC, where VR is the reference voltage signal, VC is the carrier voltage. So if the modulation index is low, that is because of the reference voltage. When the reference voltage, when the sinusoidal signal voltage is very much low, that creates over harmonics, more harmonics will be generated. That is not useful to us. If the modulation index is very much higher, then this sinusoidal signal dominates this triangular signal. Obviously, it will be clipped. Distortion, that is not useful to us. So the modulation index, it should not be very high, it should not be very less. Proper modulation index should be there. In order to control the output voltage of the inverter, if we control this modulation index, then the output voltage will be controlled. So this modulation index will be controlled by using VR, reference voltage. If we control reference voltage, output voltage will be controlled. What are the advantages? If proper voltage is maintained at the output of the inverter, unwanted frequencies will not be generated. The motor will not get heated up easily. Its lifetime will increase. It works with efficiency. Losses will be less. And it operates with a stable voltage and frequency. Our purpose is to maintain a very good, high quality, stable voltage at the output of the inverter. We are not expecting load to change according to our requirements. We have come to know the requirement of the load. We are trying to give the constant voltage to the load, irrespective of the changes in the DC input or at the AC output. This is the voltage control of the inverter by using the pulse width modulation.